Welcome to Chapter 14, Exception Handling Study Guide video. Please hit the like button, leave a comment and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free and it takes less than a minute. Let's get into it. An exception is an occurrence of an undesirable situation that can be detected during program execution. For example, division by zero is an exception. Similarly, trying to open an input file that does not exist is an exception, as is an array index that goes out of bounds. Until now, we have dealt with certain exceptions by using either an if statement or the assert function. For instance, in examples 5.3 and 5.4, before dividing sum by counter or count, we checked whether counter or count was non-zero. Similarly, in the programming example newString, chapter 13, we used the assert function to determine whether the array index is within bounds. The expression in a throw statement can be a constant value, a variable, or an object. On the other hand, there were places where we simply ignored the exception. For instance, while determining a substring in a string, chapter 7, we never checked whether the starting position of the substring was within range. Also, we did not handle the array index out of bounds exception. However, in all of these cases, if exceptions occurred during program execution, either we included code to terminate the program, or the program terminated with an appropriate error message. For instance, if we opened an input file in the function main and the input file did not exist, we terminated the function main, so the program was terminated. There are situations when an exception occurs, but you don't want the program to simply ignore the exception and terminate. For example, a program that monitors stock performance should not automatically sell if the account balance goes below a certain level. It should inform the stockholder and request an appropriate action. Similarly, a program that monitors a patient's heartbeat cannot be terminated if the blood pressure goes very high. A program that monitors a satellite in space cannot be terminated if there is a temporary power failure in some section of the satellite. A catch block that has ellipses as the parameter is designed to catch any type of exception. The code to handle exceptions depends on the type of application you develop. One common way to provide exception handling code is to add exception handling code at the point where an error can occur. This technique allows the programmer reading the code to see the exception handling code together with the actual code and to determine whether the error checking code is properly implemented. The disadvantage of this approach is that the program can become cluttered with exception handling code, which can make understanding and maintaining the program difficult. This can distract the programmer from ensuring that the program functions correctly. In Chapter 3, we noted that if you try to input invalid data into a variable, the input stream enters the fail state, so an exception occurs. This occurs, for example, if you try to input a letter into an int variable. Chapter 3 also showed how to clear and restore the input stream. Chapter 4 introduced the assert function and explained how to use it to avoid certain unforeseeable errors, such as division by zero. Even though the function assert can check whether an expression meets the required condition or conditions. If the conditions are not met, it terminates the program. As indicated in the previous section, situations occur in which, if something goes wrong, the program should not be simply terminated. When a program needs to run continuously regardless of exceptions, it is better to log the errors than to terminate the program. Examples 14.1, 14.2, 14.3 show what happens when an exception occurs in a program and is not processed. This section describes how to include the necessary code to handle exceptions within a program. The statements that may generate an exception are placed in a try block. The try block also contains statements that should not be executed if an exception occurs. The try block is followed by one or more catch blocks. A catch block specifies the type of exception it can catch and contains an exception handler. The general syntax of the try-catch block is catch, data type identifier, /exception handling code. Let us now note the following about try-catch blocks. If no exception is thrown in a try block, all catch blocks associated with that try block are ignored, and program execution resumes after the last catch block. If an exception is thrown in a try block, the remaining statements in that try block are ignored. The program searches the catch blocks in the order they appear after the try block and looks for an appropriate exception handler. If the type of thrown exception matches the parameter type in one of the catch blocks, the code of that catch block executes and the remaining catch blocks after this catch block are ignored. The last catch block that has an ellipsis or 3 dots is designed to catch any type of exception. Consider the following catch block: catch int x/exception handling code. In this catch block, the identifier x acts as a parameter. In fact, it is called a catch block parameter. The data type int specifies that this catch block can catch an exception of type int. A catch block can have at most one catch block parameter. Essentially, the catch block parameter becomes a placeholder for the value thrown. In this case, x becomes a placeholder for any thrown value that is of type int. In other words, if the thrown value is caught by this catch block, then the thrown value is stored in the catch block parameter. This way, if the exception handling code wants to do something with that value, it can be accessed via the catch block parameter. Suppose in a catch block, heading only the data type is specified, that is, there is no catch block parameter. The thrown value then may not be accessible in the catch block exception handling code. Throwing an exception. In order for an exception to occur in a try block and be caught by a catch block, the exception must be thrown in the try block. The general syntax to throw an exception is throw expression, in which expression is a constant value, variable, or object. The object being thrown can be either a specific object or an anonymous object. It follows that in C++, an exception is a value. Order of catch blocks. A catch block can catch either all exceptions of a specific type or all types of exceptions. The heading of a catch block specifies the type of exception it handles. As noted previously, the catch block that has an ellipsis or 3 dots is designed to catch any type of exception. Therefore, if we put this catch block first, then this catch block can catch all types of exceptions. Using try-catch blocks in a program. Next, we provide examples that illustrate how a try-catch block might appear in a program. A common error that might occur when performing numeric calculations is division by 0 with integer values. If, during program execution, division by 0 occurs with integer values and is not addressed by the program might terminate with an error message or might simply hang. Using C++ exception classes, C++ provides support to handle exceptions via a hierarchy of classes. The class exception is the base of the classes designed to handle exceptions. Among others, this class contains the function what. The function what returns a string containing an appropriate message. All derived classes of the class exception override the function what to issue their own error messages. Two classes are immediately derived from the class exception logic_error and runtime_error. Both of these classes are defined in the header file stdexcept. To deal with logical errors in a program, such as a string subscript out of range or an invalid argument to a function call, several classes are derived from the class logic_error. For example, the class invalid_argument is designed to deal with illegal arguments used in a function call. The class out_of_range deals with the string subscript out of range error. If a length greater than the maximum allowed for a string object is used, the class length_error deals with this error. For example, recall that every string object has a maximum length. If a length larger than the maximum length allowed for a string is used, then the length_error exception is generated. If the operator new cannot allocate memory space, this operator throws a bad _alloc exception. The class runtime_error is designed to deal with errors that can be detected only during program execution. For example, to deal with arithmetic overflow and underflow exceptions, the class is overflow_error, and underflow_error are derived from the class runtime_error. Creating your own exception classes. Whenever you create your own classes or write programs, exceptions are likely to occur. As you have seen, C++ provides numerous exception classes to deal with these situations. However, it does not provide all of the exception classes you will ever need. Therefore, C++ enables programmers to create their own exception classes to handle both the exceptions not covered by C++ exception classes and their own exceptions. This section describes how to create your own exception classes. C++ uses the same mechanism to process the exceptions that you define as it uses for built-in exceptions. However, you must throw your own exceptions using the throw statement. In C++, any class can be considered an exception class. Therefore, an exception class is simply a class. It need not be inherited from the class exception. What makes a class an exception is how you use it. The exception class that you define can be very simple in the sense that it does not contain any members. For example, the following code can be considered an exception class. Class dummy exception class are exception handling techniques. When an exception occurs in a program, the programmer usually has three choices: terminate the program, include code in the program to recover from the exception, or log the error and continue. The following sections discuss each of these situations. In some cases, it is best to let the program terminate when an exception occurs. Suppose you have written a program that inputs data from a file. If the input file does not exist when the program executes, then there is no point in continuing with the program. In this case, the program can output an appropriate error message and terminate. In other cases, you will want to handle the exception and let the program continue. Suppose that you have a program that takes as input an integer. If a user inputs a letter in place of a number, the input stream will enter the fail state. This is a situation in which you can include the necessary code to keep prompting the user to input a number until the entry is valid. The program that terminates when an exception occurs usually assumes that this termination is reasonably safe. However, if your program is designed to run a nuclear reactor or continuously monitor a satellite, it cannot be terminated if an exception occurs. These programs should report the exception, but the program must continue to run. For example, consider a program that analyzes an airline's ticketing transactions. Because numerous ticketing transactions occur each day, a program is run at the end of each day to validate that day's transactions. This type of program would take an enormous amount of time to process the transactions and use exceptions to identify any erroneous entries. Instead, when an exception occurs, the program should write the exception into a file and continue to analyze the transactions. Stack unwinding. The examples given in this chapter show how to catch and process an exception. In particular, you learned how to catch and process an exception in the same block, as well as process the caught exception in the calling environment. When an exception is thrown in, say a function, the function can do the following: do nothing, partially process the exception and throw the same exception or a new exception, or throw a new exception. In each of these cases, the function call stack is unwound so that the exception can be caught in the next try-catch block. When the function call stack is unwound, the function in which the exception was not caught and/or rethrown terminates, and the memory for its local variables is destroyed. A catch block may not have the ability to handle certain type of exceptions, or may decide that the exception should be handled by the calling block or environment. In such cases, the programmer has the ability to rethrow the exception. The stack unwinding continues until either a try-catch handles the exception, or the program does not handle the exception. If the program does not handle the exception, then the function terminate is called to terminate the program. When an exception is thrown in a function, the function can ask the user if he would like to end the program. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. If you found this video useful, please hit the like button, leave a comment and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free and it takes less than a minute. Thanks again and have a wonderful day.